So the last part of our conic section unit is we're going to solve systems of equations using conic sections. Okay, really pretty simple to do. It's just like when you solve systems of equations with lines. All right, you graph one line, you graph the other line, and the solution is where they intersect. Okay. So you solve systems of equations by graphing to start. Graph both lines, write down the coordinate where they meet. If they don't meet, you write no solutions. If they're the same line, you'd write infinite solutions on that particular line. Okay? Same thing we're doing here with conic sections. I take that back though. We're not going to necessarily graph them. Back up one step. We solve them by graphing first. But then I also taught you algebraic ways to solve them by substitution and elimination. And that's probably the method that you're going to choose to use, because you're probably not going to want to graph both conic sections and write down the coordinate of where they intersect, especially if they don't come out to be integer coordinates. So, but the idea is we're still going to solve systems of equations using conic sections, which means, you know, if you have a circle and you have some sort of ellipse. Okay, there could be multiple solutions. There could be multiple coordinates where those two shapes intersect. Okay, and it's possible they don't intersect. All right, so more likely you're going to have an answer that has two solutions, maybe some no solutions, but a lot of them will be two. Because like even with a parabola or something, okay, if you got a sideways parabola. 2 points of intersection. Okay, so I'm just trying to show you visually what we'll be doing. First one we'll do together here. You have x minus y equals 2, and x squared plus y squared equals 100. Okay? Oh, this one's not even the top one, I guess, isn't even a conic section. The top one's a line, so we'll start even easier than two conic sections. Okay. The bottom one here is a circle. Alright, so the top one's a line. What's this?
Circle.
Circle with a radius of 10. Okay, so visually you have a circle with a radius 10, and you have a line that probably looks something like this. Okay, so based on that, you're thinking two solutions, right?
Yes.
Okay, so not that you have to do this, but I'm just trying to give you guys a little bit of a visual aid as to why there are two solutions. Okay, if I were doing this, what do you think, Ben?
I would go substitution. I would get y by itself. No, x by itself on the top.
You'd say get x by itself.
Then plug it in for the x value.
Good job.
So basically you're going to have y minus 2. Well, plus 2. Sorry.
So x would equal 2 plus y, right? I add y to both sides. I'm trying to get x by itself. And the reason I want to get x by itself is so that I can take 2 plus y and substitute it in for the x in the bottom of equation. In the bottom equation of the 2. Okay? So now I have 2 plus y squared equals 100. And the rest is your basic algebra 2 quadratic equation stuff. Okay? FOIL that. So 4 plus 4y plus y squared equals 100. You have to take 2 plus y times another 2 plus y and FOIL that out. So 2 times 2 is 4, 2 times y is 2y, y times 2 is 2y, y times y is y squared.
Couldn't you just make them both equal to like y though, and then solve it like that, or is that?
Say that again.
Say, can't you make them both equal to like y and then set them equal to each other, or you know?
You could, but the problem is with this one, if you try and solve that for y, you'll have two different answers. You'll have y equals a positive square root of something and y equals a negative square root of something.
Oh,
So you're making it extra work.
gotcha.
I'd really just get one of the variables by itself and then substitute it in. So 2y squared plus 4y plus 4 equals 100.
Can you divide by 2?
You could divide everything by 2. So y squared plus 2y plus 2 equals 50.
Thanks, man.
Next,
Subtract 2.
Yeah.
subtract.
Subtract
Subtract.
50.
Subtract 50.
that.
Yeah, I was trying to make it.
So now you can factor it.
This new one is.
Multiplies to negative 48, adds 2.
6 and 8.
Oh, yeah.
8, negative 6.
Yeah.
Oops. So y plus 8 and y minus 6, set them both equal to 0. You get y equals negative 8, you get y equals 6.
You have to check first.
You're not done because you gotta get x yet.
Oh, yeah, so you plug that
Because
back
your
in.
answers are going to be coordinates.
So you plug that back in for the very first equation.
So really you got two
But-
coordinates. Something comma negative 8 and something comma 6.
So then you'll have to do
Because
it
these are y
twice.
values, right?
You'll do it
Yeah.
twice.
So substitute negative 8 in here. And you get negative 6. Negative 6 minus, or well,
Yeah, you get negative 6.
yeah, negative 6.
And then 8.
And then you get 8 on the other one. So those are your two coordinates where those two different graphs would meet. Is that the same one in the test? That's close.
Yeah, except
Yeah, it is.
yeah, the
On the bottom
second
you
one.
had x squared equals
Yeah, it
100.
is.
Yeah, it's the same.
Yeah.
You're right.
Same one. Answer look familiar.
Yeah, I got it. Finish up. He's done. How was it?
I
Class?
think I got a perfect day right here.
Check it right now.
Is
Check it
this-
on the spot.
Is that readable enough? Because I'm not gonna scale it.
I'm not gonna sit here and explain it.
Yeah. I'm gonna paid to you.
Low level math.
Grade it on the spot.
You're great on the spot.
In front of the camera
Right
and
in front of the
everything.
whole class.
The camera's on everything.
In front of the world.
Yeah.
It's on YouTube.
I
Do
can
it.
tell the world I might have meant and I got an A. I
You
might
should
have
start all your videos with "Hello YouTube."
I'm Jen.
No.
I like to do it. I'm like trash and I'm short.
And I'm doing math today.
Alright, so do another one here. 9x squared minus 4y squared equals 36. X squared plus y squared equals 4.
Two circles.
Circle and
Oh.
yeah, pergola, yeah.
Sure is. Golly gee.
Sure don't it?
Circle with a hyperbola.
So would you get x squared by itself?
I would either get x squared by itself or y squared by itself here, okay? I'd probably choose x squared because the x squared one is positive in that top one. So I got x squared equals 4 minus y squared. If I subtract y squared from both sides, then I take 4 minus y squared and substitute it up in that top one. So 9 times 4 minus y squared minus 4y squared equals 36. 36 minus 9y squared minus 4y squared equals 36. Negative 13y squared equals 0. Now this one's going to come out pretty nice. So then y is just going to equal 0, right? The good
Why?
thing is you don't, what's that?
Why does y equal 0?
Well, if you divide by negative 13, you have y squared is still equal to 0. Right? Because 0 divided by negative
yeah.
13 is still 0. So then I have y squared equals 0, and then when you square root 0, you just get 0, right? Square root of 0 is still 0. Plus or minus 0, you don't need to worry about plus or minus on the 0. Okay? So y equals 0, so that's really pretty nice. That's the only solution for y. Plug 0 back in for y. So x squared plus 0 equals 4. X squared equals 4. X equals plus or minus 2. So what are my two solutions? 2, 0, and negative 2, 0.
Can we just put like
Plus or minus 2, comma 0 would work, yep. So those would be the two coordinates where the hyperbola and the circle intersect one another. Okay? So that's kind of the general idea. We'll do a couple more together here, but I am going to shut down the video because they're basically the same. So.
Bye, YouTube.